Okay, so today we're talking about slope. And as we were just mentioning, slope really refers to the steepness of a line. Luckily, we can describe slope with a numerical value. Usually, we like to think of that as a fraction, and I know you normally steer clear of fractions, but slope is one of the places where you actually want a fraction, or it's helpful to think of as a fraction, okay? Because what slope really is, first of all, do you know the letter that represents slope? M. Super weird, right? And I actually don't know why it's an M instead of an S or a who knows what, but it's an M. So we use the lowercase letter m to represent slope. And in order to calculate the steepness of a line or slope, we do what's called the rise over the run. So this is, again, just a fancy way. The rise is saying, so it's your change in vertical distance. How much are you going up or down? And then the run, exactly. Okay, so, and again, that's left or right. Sometimes you might see slope represented like this. Has anybody ever seen that before? Have you used this symbol, this little triangle symbol? It's actually not a triangle at all, but maybe you've seen it in, do you guys take physics? Yeah.
Yeah, I was in physics, and it's like a delta and represents change.
Exactly. It's actually a letter, a Greek letter called delta, and it stands for change in. So change in x, or I'm sorry, change in y over change in x. So again, that's a letter called delta. We usually just draw it like a triangle, but it actually is a letter, delta, and it means change in. So you'll see it a lot in physics, you might see it in chemistry, sciences use it a lot anytime you're doing some sort of a change in temperature or speed or distance or whatever it is. So if you have a formula and you see those in there, that's all it is. Okay? Usually we stick to rise over run, but this pops up occasionally. All right, great. So let's say I had a coordinate plane. So I'm just going to sketch one. And let's say I had 2 points. One of them is at, I don't know, how about 1, 0? And let's put the other one at maybe 3, 1. So what I can do is I can mathematically figure out how steep that line is. I can assign it a value. And here's how we do it. We're going to take the difference in the y. So I'm going to take the 2 y values and subtract them. And I'm going to do the same thing with the x's. Now, this formula looks a little confusing at first, but it really isn't. Let me explain what these little tiny numbers are. Go ahead, you tell me.
Second y minus the first y over the second x minus the first y.
Yeah, that's all these are. See how I have 2 points? I just need to know which one I'm talking about. So that's why I have little 2's and 1's. Because I'm either talking about the first point or the second point. And it actually doesn't even matter which one's which. You could call this the first point or that one. It doesn't matter. As long as once you pick, you stick with it. So, it might be helpful. I just usually go left to right. So this one comes first. So that's just the x coordinate of my first point. So that's why he's got a little tiny 1 on the bottom of it. This guy is the y coordinate of my first point, so he's going to be y By the way, the right way to say it is y sub 1, x sub 1. Sub meaning down. So a subscript is when you write it down little like that. A superscript is when you write it up top like an exponent. Right? So if you wrote x squared, the 2 would be up. But if you have a subscript, it's down. Okay? So there's x and y of my first point, and then here's just x and y of my second point. So that would just be x sub 2 and y sub 2. So if this is my formula, I just have to plug in all the numbers wherever they go, right? So m equals, let's see, y2. What's y2 in this? 1, right? y2 is 1. So 1 minus y1 is 0. Then downstairs, x2 would be 3 minus x1, which is 1. Ta-da! And now I just do the math. So 1 minus 0 is just 1. 3 minus 1 is 2. And guys, I'm done. Okay, the only things that you may have to reduce this fraction here. So if it came out to be like 4/8, I would just reduce it to be 1/2. Okay, so you do want to, let's put a star, always reduce your fraction. You never want to turn it into a decimal though. Because remember, the formula for slope is rise over run. You want those two numbers. So you're never going to give me slope, or it's very rare that you would actually want the slope as a decimal. It just doesn't make sense. You want it as a fraction. And you'll see when we go to graph it, it makes a lot more sense to have it as a fraction because it's going to tell me how many boxes to go up and then how many boxes to go over. So if I don't have that as a fraction, now I'm like, well, okay, well, where am I going? So if you mistakenly make your slope into a decimal, you're really just going to have to turn it back into a fraction. So don't do it. So we actually like fractions for slope here. Just reduce them. So far, so good? Is this old news? You all knew this already? Oh, well. Should be an easy section then, right? What kind of numbers can slopes be? So let me rephrase that. Could I have a negative slope? What would that look like as far as the graph is concerned? Exactly. If you have see as I'm going from left to right, this line is going up, so it has a positive slope. If the slope were going down from left to right, it would have to have a negative slope. So if m is positive, line goes up from left to right. So, on the other hand, if m is negative, line goes down. I suppose this is as good a time as any to think about all the different kinds of lines you could draw. Are they all either going up or down?
You should be all set.
Yay,
If you
thank
need
you.
anything else, just let us know.
I will, thank you so much. Yeah.
You could have zero slope.
What would that look like?
It would just be like a straight line going across the wire.
Yes, you can have horizontal lines, right? That's perfectly a flat line, so it's not sloping up and it's not sloping down. So here's what's interesting about that. Let's do out the math. So let's say I had a coordinate plane and I picked 2 points that were on the same horizontal line. Okay, so let's say this was my horizontal line right here. And I picked 2 points that were on it. So let's say I picked this one, which is, what's that, -1, 1. And then I picked this one right here, which is 2, 1. Let's see what happens when we find the slope of this line. So again, I have x1, y1, and I have x2, y2. Alright, so if we are going to follow the slope formula, which remember we have right, there it is, right up here. I need y2 minus y1. Actually, while I'm thinking of it, the most common mistake with slope is sometimes kids accidentally put the y's on the bottom and they put the x's on the top. Be careful. It's always y's on top, x's on the bottom. Alright, so I have the formula right in front of me. I want to do y2. What's y2 in this case? 1 minus, what's y1? Also 1. Interesting. Downstairs, x2 is 2. Now, this is important. This hasn't come up yet. I want to do x2, which is 2, and I want to minus x1. So I want to do minus -1. Right. What happens when you have minus a negative? Turns into a plus. So you really have 1 minus 1 is 0 up top, but downstairs that's 2 plus 1. Be careful. Signs are messing up the signs is probably the biggest mistake. Second biggest mistake is probably putting the x's on top and the y's on the bottom. You got to be super careful with these negatives. So minus a negative turns into plus. So now I have 0 over 3. Well, what is 0 divided by 3 anyway?
0.
It's just 0. So that means a horizontal line has a slope of 0. How interesting. What do you suppose a vertical line slope would be? Let's find out. So, I'm going to do the same thing, but I'm going to have a vertical line now. So, vertical line, here we go. Let's say we took the following points. Let's say we took this one, which is at 1, 2. And let's take this one, which is at 1, -1. Okay, I've got a vertical line. I again have x1, y1, and x2, y2. Okay, let's plug in the pieces. What is y2? -1 minus, what's y1? 2. Downstairs, I want x2, which is minus x1, which is 1. Okay, so what's my numerator going to be? If I have -1 minus 2, what'd you say? -3 is correct. Does everybody agree? Right? -1 minus 2, I got -3. And then in my denominator, 1 minus 1, of course, is 0. So what's -3 divided by 0? Let me ask Mr. Calculator for assistance. If I do -3 divided by 0, let's see, there we go. -3 divided by 0. So, this is, okay, I take it all back. This is probably the most common mistake, right? If you have 0 in the denominator, you know what? I just thought of another way to describe this. This is terrible. Imagine that this was like Like this was a piece of wood, and you're standing up here. If there's nothing under the piece of wood to hold you up, that's pretty bad. You're going to fall, and you're going to hurt yourself. Here, this is, okay, it's me standing on the bottom, and I'm holding nothing above my head. Okay, that's fine. I can do that. I'm not going to get hurt. I get to hold up nothing. This is terrible. There's nothing down there. I'm going to fall and crash. Owie. You cannot have 0 in the denominator. This is not 0, and it's not -3. When this happens, the whole world breaks. It's called undefined. Yes, undefined is the answer. So I can give you my little explanation of why this is what it is. If I had, I don't know, let's assume that there's 12 of you sitting right here, okay? If I had brought in a dozen donuts, so that's 12 donuts, right? Couldn't I have given you each a donut? I could have, right? I didn't. I wish I did, but I didn't. But you could imagine that, right? Let's say I had one donut. Couldn't I break it up into 12 parts so we each get a little part of it? Yeah, it would just be a little nibble, but at least I could do it, right? I could. I could take 100 donuts and divide it into 12, and then we all get a bunch of donuts, right? Right? You with me? Okay. Could I take half of a donut and break it up into 12 so we each get? You could, right? If I only had half a donut, I could do it. You would just get a little tiny piece. Tiny piece. Right? You with me? Okay. If I didn't have any donuts, and let's say I had an imaginary plate, so I don't really have any donuts, could I give you all an imaginary donut? Yeah, right? Like, didn't you ever have a little person make you have a tea party? And there's not really tea in that pot, right? They're just pretending. Same thing. I just pretended to give you all a donut. I have 0 donuts. You all got 0 donuts. So that's essentially what I did here. I had 0, and I divided it not by 3, but by 12. And what'd you get? You got 0. So I can take nothing and divide it into as many parts as I want. Just each part is nothing, right? I have no donuts, but I could divide it into 12, so you all get a piece of my imaginary donut. How many actual donuts did you actually get? None. Are you with me so far? Are you following this? Okay, so here's the problem with this. So forget that that's a negative, even if it was a positive. Say I really did have 12 donuts in real life. I have 12 donuts. Imagine these are donuts. Okay? I have 12 donuts in my hands. How could I divide them into no parts?
Just like this.
But then I am actually dividing it into one group. I'm keeping it as one group. So 12 divided by 1, I still would have the 12 donuts. I can't divide it into no parts at all. That would almost be like trying to make it disappear. I could take 12 donuts and divide it into 24, and then everybody would get half a donut in that situation, right? If I really had 12 and I had 24 kids, okay, everybody gets a half. So I could divide it by a half. I could divide it by 1 and say, sucks for you guys, I'm keeping all the donuts, right? So now I get to keep all 12 of my donuts, but I can't literally divide them into nothing. They exist. I really have them. You could throw them out the window. Okay, well, now they're just out the window. They're still there. You could eat them. Okay, well, now they're just in your stomach. They're still there. You can burn them. Well, they're still there. It's just burnt, right? It's not Hogwarts. I can't snap my fingers and make them disappear. They're there. So you can't divide them into nothing. I could change them into other things, right? I don't know, if you felt like burning it. Oh, why would you ever burn donuts? I don't know. But you could then burn it. Now you've turned it into trash. You get what I'm saying? But they don't just go away, right? So you can't divide by nothing. It is impossible. So that is what we call undefined. All right, so that's sort of my lengthy explanation of why that is what it is. And I hope that helps a little bit. But a 0 in the numerator is totally fine. 0 divided by 3 really is just 0. That just means, hey, I have nothing. I'm going to divide it into 3 so everybody gets nothing. This is I really have something and I'm trying to divide it into no groups. Impossible. Can't do it. If it helps you to think of, oh, I'm standing on a platform, if you will, and now there's nothing underneath there to hold me up, that's bad. That's undefined. I'm going to fall. I'm going to get a boo-boo. So, can't have that. But I could stand underneath a platform with nothing above me all day long. That's fine. Nothing's going to happen. Here, that's bad, though. That's very unstable. Okay. So, there's my spiel about that. Now, there is another way for you to remember all of this, because it gets very confusing and it's all sort of there, but you already know this way. What thing should be going off in your head anytime you see a horizontal or a vertical line? Yes, hoi bucks. We have really only been talking about the last letter and the first letter. If it was y equals, it was horizontal. If it was x equals, it's vertical. The middle letter now comes into play. That's slope. So for y equals, right? So that was our example up here. Well, I didn't give you the equation of the line, but that's okay. I had a horizontal line. Well, the equation of this guy, we'll get there in probably after vacation. His equation is actually y equals 1. Which, yes, you don't know that yet, but that's okay. You know that it's a horizontal line, so now you know the middle letter tells you what the slope is. So his slope is 0. And he will also be a y equals. This one, his equation is x equals 1. So he's an x equals, he's a vertical line. U stands for undefined. So the middle letter tells you what the slope of that line is going to be. So this is really the most concise way I've ever seen to kind of put all of those pieces together. That horizontal lines have a slope of 0 and their y equals whatever the y is. Vertical lines have undefined slopes and their x equals whatever they are. Hoi bucks. Such a great little tidbit. But now you know why it is what it is. Right? So, okay. Let's try. Let me give you a couple to try. So, just some random ones. Maybe they'll be horizontal, maybe they'll be vertical, but they're probably going to be something like this. They're going to have some sort of slope, and you try and find it. So, you're going to use your equation right here, your formula. y2 minus y1 over x2 minus x1. Let's see if we can find the slopes of the following. Whoop. All right, let's try, how about 8, negative 4. And negative 2, 6. All right. So in this one, I'm not even giving you the graph. I'm just giving you the 2 points. And then maybe I'll try and mix it up. I'll give you a couple of different ways. Where's the thing that I need? Not here. Of course not. What the heck? Oh. Let's do. I'll do it down here. Where's the second one I want you to try? So one I'm just giving you the 2 random points, and the second one I'm giving you a graph. Let me zoom in a little bit so you can try and find those points better. Okay, did everybody get something for each one? All right, so let's start off with the first one. So I just gave you the numbers, so you're just going to pop the numbers into the formula, right? So y2 minus y1. So I want to do 6 minus negative 4, right? Did you do 6 minus negative 4?
Yeah.
And then on the bottom, I'm going to have negative 2 minus 8. So please check that you have the pieces in the right spot. Now, since I have minus a negative, that turns into 6 plus 4, doesn't it? And then the denominator, what's negative 2 minus 8? Negative 10. So I get 10 over 10, negative 10, negative 1. If your slope is a whole number, so it doesn't come out to be a fraction like a half or 2/3. It comes out to be 1 or 7 or 9. You can just write it as that whole number. You don't have to put it over 1, but you're certainly not wrong if you do. Right? If I go to graph it, I just know that the denominator of a whole number is just going to be a 1. Right? So if I want to write the number 5 as a fraction, I know I'm going to write it as 5 over 1. Okay? So just keep that in mind. Now, if I'm looking at so what could you tell me about this line? I know we don't even have a picture of it, but what could you tell me about it? It's got to be going down from left to right because the slope is negative. So even though I didn't even plot these points, if I were to, and I connected them, I would know it would be going down from left to right. Just like when I look at number 2 here, tell me what you know about the slope right away. Going up, right? From left to right, we're going up. So if this were, I was doing some sort of multiple choice thing, any slopes that are negative, I would know right away are wrong. They have to be. This is a huge thing that I need you to be checking because it's so easy to check if you should be getting positives or negatives. So when I go to do the math on this, if I end up with a negative slope, I know there's an error somewhere. Okay? Yeah.
There's like a way that I did it without having to do the math. You just count how many squares up to the next point and count how many.
Yes, and you absolutely can do that. If you have a graph, yeah.
And maybe stuff.
Sure, go super fast. If you have a graph and you have 2 points that are kind of labeled sort of nicely like this, remember that slope is just rise over run. So without having to figure out what these ordered pairs are, which you totally can, right? I have one of them at -1, 2, and another one at -2, -3. So I could figure out what the points are and then plug them into the formula. Totally doable. However, if you are lucky enough to have a graph, you can just count how many boxes you're going up and then how many boxes you're going to the right. Just make sure that you are always moving from left to right when you do that. So if I were to do that, I'm going up 1, 2, 3, 4, 5 boxes up, 1 box to the right. Since I went up, it's going to be positive, so I have a 5 over 1, or just 5. Did everybody get that for number 2? So let's try another one. Say I was looking at number 4 here. Tell me what you know about the slope right away. It's got to be negative because I'm going down. So here's how I would do that if I'm just doing the boxes and I'm not actually plugging the numbers into the formula. I went down 1 to the right 2. So because I went down 1, what do you think I put as my numerator? Negative 1, right? Because I went down. You're always going to be moving to the right. So the bottom number should always be positive because I'm either going to go up or down and then I'm moving to the right. So as long as you are moving from left to right, right? So here again, if I'm looking at this one, I'm going down 1, 2, and then I'm going to the right 1, 2, 3. So this slope would be negative 2/3, down 2 over 3. Do you see that? So, yes, you can do that as long as you also don't want to have too many boxes to count. Like if there's like 100 boxes to count, that doesn't make any sense. You would just find the coordinates and pop them in. So I'll just just so we have our notes complete. So if I had one like this one, I know it's hard for you. There are actual little tiny marks on this grid. I don't think you guys can even see them. Can I turn this light on? Do you see that there's little tiny gray dots? Can you see them? No, kind of. There are. So this guy's at 1, 1. This is at 2, 2. So if I went from one to the other, positive slope, right? I'm going up how many? Oh, it's supposed to be 1. Oh yeah, it's hard to see. So anyway, I'm going up 1 over 1. So my slope here would be 1 over 1 or just 1. So yeah, you can totally get away with counting boxes as long as they're countable boxes. One more, and then I'll have you practice some. Actually, I have a scavenger hunt for you. I'm so excited. We'll do one more. How about, I'm going to give you the random points. How about 4, negative 5, negative 2, negative 1. We got answers? Pablo, what's your answer?
Negative 2/3.
Negative 2/3? Oh, that's funny, because I just used that example. Is that what you got?
No, I got
Negative 1/2. Oh, interesting. All right, let's try it. So I want to do y2. What's that?
Negative 1.
Negative 1. Minus y1, which is... So I have minus negative 5. So I know I'm going to have to fix that. Okay, downstairs, x2 is negative 2 minus x1, which is 4. Okay, so my numerator, now let's be careful. Negative 1 minus negative 5. So that means it's negative 1 plus 5. Correct. So my new numerator is going to be positive 4. My denominator, let's be careful. Oh, you guys can't even see it. Oh, okay. So negative 2 minus 4, you are correct. That gets me a negative 6. Now, you're not going to leave a slope like this. First of all, with slopes, see how I have a negative in the denominator? You really don't want it there. You really, if you have a negative, you really just want to move it upstairs. So not only do I want to move that negative upstairs, I want to reduce 4/6 to, yes, negative 2/3. So that is how you would want to write that fraction. There's your slope between those 2 points, a negative 2/3. Okay, so if you do end up with a negative in your denominator, move it up. What happens if you have a negative in the numerator and the denominator?
It just turns into
Yeah, don't forget that it's positive. So, for example, if you had like negative 4 over negative 5, isn't that really just positive 4/5? Right? Because negative over negative is just positive. So you shouldn't ever finish with a negative on top and on bottom, because it would just be a positive. But if you do have a negative and it's downstairs, just move it up. All right, you guys ready for this scavenger hunt?
sure.
Okay, let me stop.